In this video, I'll describe the present state of development progress on the Brain Simulator 2. But first, I'll briefly review the intent of the project and the overall architecture of the system. My overall hypothesis is that AGI requires a minimal set of functionality, including interaction with reality, 3D modeling, knowledge, planning, and goals. My reasoning for this minimal set is spelled out in other videos on the Future AI channel and in my book, Will Computers Revolt? Further, I contend that with sufficient processing power, AGI could be created from just this collection of functionality. Even if it turns out that AGI requires more features, it is likely that interesting and useful results will emerge from this project. These minimum requirements map generally to software modules I am developing within the framework of the Brain Simulator 2. The Brain Simulator itself consists of an engine simulating a large array of simple neurons combined with the capability of adding arbitrarily complex software modules. The underlying engine for the Brain Simulator currently runs as expected. It is fast, and I have tested it with an array of 1 million neurons and 10 million synapses with real-time performance without GPU acceleration. It runs properly in parallel across the multiple cores of a desktop CPU. I consider the engine to be about 50% complete because I anticipate that future module development will require additional engine features in addition to the enhancements needed for GPU acceleration. The user interface also works well, so we'll call it 50% complete as well. Now for the modules which make up the basis of intelligence. For inputs, I have implemented vision and speech recognition modules. For vision, there is a camera module and a virtual reality module. These put data into the network in an identical manner, which is necessary for testing. The speech recognition module uses the Windows speech engine, also used by Cortana, which has a more or less fixed vocabulary. So although we might call this module only 5% complete because of its limitations, we might also say that this module, as implemented, is adequate for experimentation in AGI and so is 100% complete. Eventually, this module could be replaced by a much more general one which can accept arbitrary sounds and infer words. I have adopted the agile programming approach of first developing for a single use case for the entire end-to-end system, then coming back and filling in additional features. As an example, the portion of the vision processing system which detects points of interest can only recognize right angles, so the system is presently limited to recognizing rectangular objects. On the other hand, all the downstream processing can accept objects of arbitrary complexity once they are recognized. So although I have written lots of vision-related software, I'll give the current completion at only 5%. I have implemented a 3D spatial module, an internal model of surroundings, which can keep track of objects with various attributes and at arbitrary 3D positions and handle the processing needed for a robot to move through its environment while keeping track of the relative positions of all the objects in the internal model. With minor enhancements, it will be able to detect objects in motion and differentiate these from the robot's motion. What I call the knowledge base detects and stores relationships between objects and words and everything in the environment. For example, it can determine that a red square is similar to a blue square in that the shape attribute is similar. I have developed 3 versions of the knowledge base, but only just begun creating the correlation system which would allow it, for example, to associate a word input with a shape or color input. I have written a Hebbian learning module, but I'm looking forward to a vastly more efficient method, so we'll give this 5% complete. 2 key modules which I haven't begun to develop are planning and goals. The robot needs to decide what to say or do based on goals and previous experience. These 2 modules are the top development priority, so I can complete the end-to-end single case data path for my AGI. Then I will go back and enhance all the modules as the behavior of the system dictates. On the output side, there is a speech module and some robotic controls. I have built a minimal wheeled robot, which has vision, hearing, motion, and a single manipulator. As my development of the brain simulator proceeds, I'll create short videos of interesting results as I encounter them. Be sure to subscribe to this channel to follow along. For more on this timely topic, read my new book, Will Computers Revolt? Preparing for the Future of Artificial Intelligence. Available now at Amazon and book retailers worldwide in paperback, hardcover, and ebook editions.